mic off பண்ணுங்க ரமேஷ். So, differential geometry continuation. So, this is called Dupin's Indicatrix. That is the geometrical construction. Is a geometrical construction in the tangent plane. In the tangent plane of the surface that provides the local visualization of the normal curvature in the different direction. That is called the Dupin's Indicatrix. And mathematical definition at a point P on the surface S, Dupin's Indicatrix is the set of points Q in the tangent plane. That is the distance of P to Q is 1 by square root of mod of kn of theta. That means cos of n theta. That is the normal curvature in the direction PQ. Normal curvature in the direction PQ. That is the coordinate system for that. When you use the Euler's formula, that is kn of theta equal to k cos of 1 cos square theta, cos of 2 sin square theta. The equation of the Dupin's Indicatrix, that is the cos of 1 x square plus cos of 2 y square equal to plus or minus 1. The tangent plane coordinates, the Dupin's Indicatrix should be satisfy the cos of 1 x square plus cos of 2 y square equal to plus or minus 1. And the classification of the Gaussian curvature, elliptic point, that is elliptic point at the kappa equal to 0, and the kappa 1 kappa 2 have the same sign now. Then x square by a square plus y square b square equal to 1, a equal to 1 by root of kappa 1, b into the 1 by root of kappa 2. So this is an ellipse. And hyperbolic point the kappa is less than 0. In this case, x square by a square minus y square by v square equal to 1. That is minus 1 or plus 1. Because of the hyperbolic formula, x square by rendu type x square by a square minus y square by b square equal to 1, or y square by b square minus x square by a square equal to 1. So adanal inga plus or minus 1. So in this case, a is should be root of mod of k kappa 1, b into the root of 1 by root of kappa 2. So this is the hyperbola. And the parabolic point na kappa equal to 0. So when principal curvature is 0, that means x square equal to 2py and y square equal to 2px. So this is called the parabola. And the radius of curvature in this case 1 by root of kappa and theta. In this Dupin's Indicatrix, the r of theta equal to radius of curvature, that 1 by root of kappa and theta. Kappa and theta is the normal curvature. And the asymptotic direction for the hyperbolic points, the asymptotic hyperbola corresponds to the direction of the zero normal curvature. Direction of zero normal curvature. The principal direction for the axis of the indicatrix aligns with the principal direction. Example for the sphere, that is for the sphere of radius capital R, kappa 1 kappa 2 both are equal to 1 by r. And Dupin's Indicatrix x by x square by r square, y square by r square, this is equal to x square plus y square equal to r square. The circle of radius or all directions have the same normal curvature. The circle of, this is a circle of radius r, so that means all direction have the same normal curvature. Another example is the cylinder of radius r, then kappa 1 equal to minus 1 by r, kappa 2 equal to 0 for this cylinder. So kappa 2 equal to 0 now, since kappa 2 equal to 0, we have the parabolic point. So that is Indicatrix, the Dupin's Indicatrix x square equal to 2r into mod y, or 2r into mod y. The parabola is opening in the y direction, upward or downward, depend on the y value. and saddle point என்றது that is z equal to xy at the origin. Kappa 1 equal to 1, kappa 2 equal to minus 1. The Dupin indicatrix is x square minus y square equal to plus or minus 1. So this is called the rectangular hyperbola. And set of the principal coordinates, set up in the principal coordinates. So that is principal coordinates means f equal to m equal to 0. The fundamental forms I equal to e du square plus g dv square because of f equal to m equal to 0. The second fundamental form பார்த்தீங்கன்னா that is L du square n dv square. This is a very important. ஏன்னா first fundamental form, second fundamental form ரெண்டுமே மாதிரி பண்ணியிருப்பீங்க. அதில் just replace f equal to m equal to 0. So the kappa 1 என்றது இங்கே L by E and kappa 2 என்றது n by g. Okay. And the normal curvature பார்த்தீங்கன்னா the direction for a direction du, dv, the normal curvature is defined as L du square plus n dv square divided by e du square plus g dv square, second form divided by first form. And the parameterization of the indicatrix and the parameterization, the x equal to root e du, y equal to root g dv. So this is called the parameterization, this is called the normal curvature. And in the parameterization formula, the normal curvature how to define, that is k kappa 1 x square plus kappa 2 y square divided by x square plus y square. And the definition of by the definition points on the indicatrix, r square equal to 1 by kappa n, that is equal to x square plus y square divided by kappa n ன்றது நமக்கு தெரியும், அது reciprocal எடுத்தீங்கன்னா we get this one. So from this mod of k1 x square plus mod of k2 x square equal to 1, so this is implies x square plus y square equal to r square என்றதுனால. So depending on the sign of this one, we get the different cases. So skip this is torus, this is the advanced example for that. Kappa 1 equal to 1 by r in this case, kappa 2 equal to cos u by r plus r cos u. So the major radius is capital R, minor radius is small r. So indicator changes the type, outer part on the cos u greater than 0, that is ellipse, and top and bottom on the, that is called the cos u equal to 0, that is become the parabola, and inner part on that is the hyperbola. So leave it the advanced example மட்டும் கொஞ்சம் லைட்டாக பார்த்துங்க. And the computational aspect, that is the algorithm for drawing the indicatrix. Now first of all, principal curvature kappa 1 kappa 2 at the point P, and determined the type based on the Gaussian curvature kappa equal to kappa 1 kappa 2, and conic in the tangent plane, and appropriate conic in the tangent plane. So the numerical computation, that is leave it, and find the Dupin's indicatrix for z equal to x square plus y square. This is the sum curve. So first of all, இதனுடைய parametric form பார்த்தீங்கன்னா x equal to u, y equal to v, so then z equal to u square plus v square. So this is the R parameterization form of the surface. So what is the fundamental form at the point origin? At the point origin, that is RU, இதிலிருந்து R கண்டுபிடிச்சாச்சு. So RU கண்டுபிடிக்கலாம், differentiate with respect to u, differentiate with respect to v, differentiate with respect to u, once again u, RUU, and differentiate with respect to u with respect to v, இதை வந்து with respect to v பண்ணலாம். And so at the point origin நம்ம find out பண்ணுறோம், that's all idea. So வேணா ஸ்பெஷலாக போட்டுங்க. And RVV என்றது differentiate v with respect to once again v. So what is RU? RU is 1, 0 and 2u. This is the idea. RV என்றது that is 0, 1, 2v. Correct? So RUU என்றது இது எல்லாமே at the point origin நம்ம find out பண்ணுறோம். So then we get this result. RU என்றது RU differentiate once again with respect to u, that is 0, 0, 2 னு வரும். இதே மாதிரி RUV என்றது once again differentiate with respect to v, so RUV equal to 0, 0 and 0. okay, yeah, with respect to v பண்றதுனால 2v 0. Like this we get this one. And fundamental form, from the fundamental form E equal to, இது எல்லாமே find out பண்ணியாச்சு. So fundamental form formula apply பண்ணி E1 F0 G1 L2 M0 N2. And when you apply the principal curvature, the kappa 1 equal to L by E. இப்போதான் பார்த்தோம். இதெல்லாம் கொஞ்சம் மெமரைஸ் பண்ணி தான் ஆகணும். And kappa 2 equal to N by G. So and Dupin's indicatrix என்ன சொல்லுதுன்னா kappa 1 x square kappa 2 y square equal to 1. The 2x square 2y square equal to 1. The x square plus y square equal to 1 by 2 னு வருது. This is called the Dupin's indicatrix. எதை ரெப்ரசன்ட் பண்ணுது இது? The circle of radius 1 by root 2. ஏன்னா 1 by 2 right side இருக்கு, 1 by root 2. That is called that another Dupin's indicatrix. And find the asymptotic direction using Dupin's indicatrix. Asymptotic direction for the hyperbolic point, yeah, kappa 1 equal to greater than 0, kappa 2 less than 0, hyperbolic point la. So very earlier பார்த்தோம் elliptic point and hyperbolic point na. The indicatrix is kappa 1 x square kappa 2 y square equal to plus or minus 1, and that is Dupin's indicatrix. So இங்க asymptotic satisfy the kappa 1 x square plus kappa 2 y square equal to 0. Asymptotic direction to this is equal to 0. In this case y equal to என்ன வரும் அப்படினு பார்த்தீங்கன்னா இதுல இருந்து y கண்டுபிடிச்சீங்கன்னா முதல்ல இந்த சைடு ரைட் ஹேண்ட் சைடு கொண்டு போயிட்டு y equal to kappa 2 y square equal to minus kappa 1 x square and then divided by kappa 2, then square root எடுத்தீங்கன்னா plus or minus this one வரும். So the direction, this direction correspond to the zero normal curvature. So the normal curvature kappa n equal to kappa 1 cos square theta of kappa 2 sin square theta equal to 0. From this equal to 0, so from this tan square theta, இந்த k2 kappa 2 sin square theta இங்கே வச்சுட்டு அந்த சைடு கொண்டு போனீங்கன்னா tan square theta equal to minus kappa 1 by kappa 2 னு வந்துரும். Okay, so the asymptotes of the Dupin's indicatrix give the asymptotic direction of the surface, asymptotic direction of the surface. And the classification, the indicatrix can be various types of quadrics, that is called the ellipsoid and hyperboloid and paraboloids, depending on the signs of the principal curvature, depending on the signs of the principal curvature. The next one, surface revolution. That is, surface revolution means is generated by the rotating the plane curve. Rotating the plane curve, that is called the generating curve or meridian அப்படினு சொல்லுவாங்க. Generating curve or meridian, that is generated by the rotating plane curve, that is called the surface of revolution அப்படினு சொல்லுவோம். About what na? About a fixed straight line. That fixed straight line is called the axis of revolution. And the fixed straight line is axis of revolution, and rotating the plane curve, that is rotating plane curve is called a generating curve or meridian. Okay, so what is the mathematical definition? பார்த்தீங்கன்னா the generating curve in the xz plane la x equal to g of u, z equal to f of u, y equal to 0 in the xz plane la. Rotating this curve in the xz plane la இருக்கிற curve, generating curve is in the xz plane, that is given that in the parametric form like this. So rotating this curve about the z axis, about the z axis na r of u comma v என்ன வரும்? g of u cos v and g of u sin v and f of u into f of u, z is f of u. So where u என்றது parameter along the generating curve, v என்றது rotation angle, that is 0 to 2 pi, and g of u என்றது greater than 0, that is distance from the axis, that is called the radius function சொல்லுவாங்க. f of u என்றது height function. And fundamental properties பார்த்தீங்கன்னா the coordinate curves meridian, that is v equal to constant, the position of the generating curve, and parallel சொல்லுவோம், that is coordinate curve or parallel, that is called the u equal to constant, that is called the circle of latitude நம்ம சொல்லுவோம். orthogonality பார்த்தீங்கன்னா that is surface revolution, the coordinate curves are orthogonal அப்படின்னா f equal to ru dot rv equal to 0 னு அர்த்தம். ru dot rv equal to 0, that means f, that is called the orthogonality condition. And first fundamental form apply பண்ணீங்கன்னா for this I equal to g dash of u whole square f dash of u whole square into du square plus g of u whole square into dv square, because of f equal to 0. And examples of the common surfaces of revolution. The sphere என்றது generating curve semicircle of radius r. Generating curve வந்து semicircle of radius r. So g of u equal to r sin u, f of u equal to r cos u. The u is lies between the 0 to pi because of it's a semicircle of radius r என்றது. Parameterization பார்த்தீங்கன்னா r sin u cos v and r sin u sin v. And this is called the g of u இல்லையா by the parametric form. And f of u வரும். f of u என்றது r cos u. So அதை கொஞ்சம் memorize பண்ணணும். So this is the picture like that. Cylinder, another example is the cylinder. Cylinder பார்த்தீங்கன்னா generating curve என்றது vertical line. Okay, vertical line is the generating curve. அப்படின்னா g of u equal to r, f of u equal to u, and the parameterization r cos v, r sin v, f of u என்றது u, அதனால u ன்னு வந்துரும். Cone, another example is a cone. கோனுக்கு பார்த்தீங்கன்னா generating curve வந்து straight line through origin வழியா பாஸ் ஆகிற straight line. And g of u equal to u, f of u equal to, that is u cot alpha ன்னு வரும். The u is greater than 0. இதனுடைய parameterization u cos v, u sin v, the f of u அப்படியே வந்துரும். Okay, another இது one torus. Torusன்றது எல்லாத்துலயுமே வருது இந்த example, that is called the circle. Okay, well, generating curve is the circle for this one, and g of u equal to r plus r cos u, and f of u என்றது r sin u. So இதனுடைய parametric form r plus r cos u cos v, r plus r cos u sin v, the f of u மூணாவது வந்துரும், that is the f of u r sin u. Okay, இதுல ப்ராப்ளம்லாம் கொஞ்சம் லென்த்தியா தான் இருக்கும். ஓகே, ஜஸ்ட் இது பேசிக்கா தான் கேட்கறது வாய்ப்பு இருக்கு. இதெல்லாம் கொஞ்சம் எலிமெண்ட்ரியா படிச்சு வைக்கிறது நல்லது. ru, that is parametric form தெரியும். The fundamental forms and curvature. What is ru, rv? From this how to construct the e and f, g and I equal to, this is the form. This is the first fundamental form. Already நம்ம ரிசல்ட்டா பார்த்தோம். செகண்ட் ஃபண்டமெண்டல் ஃபார்ம் வேணும்னா ruu வேணும், ruv வேணும், rvv வேணும். எல்லாத்தையும் யூனிட் நார்மல் n equal to something and l, m, n இது எல்லாமே ஃபைண்ட் அவுட் பண்ணலாம். அண்ட் செகண்ட் ஃபண்டமெண்டல் ஃபார்ம் lu ஸ்கொயர், l du ஸ்கொயர் அண்ட் n dv ஸ்கொயர். lன்றது இது, nன்றது இது. ஓகே, அண்ட் பிரின்சிபல் கர்வேச்சர் பார்த்தீங்கன்னா that is fem equal to 0. The coordinate curves are lines of curvature. Kappa 1 equal to L by E formula எடுத்து substitute பண்ணுங்க, that is called the meridional curvature சொல்லுவோம். Kappa 2 equal to N by G, this is called the parallel curvature. And Gaussian curvature பார்த்தீங்கன்னா Kappa equal to Kappa 1, Kappa 2 ரெண்டுத்தையும் ப்ராடக்ட் பண்ணணும். ரெண்டுத்தையும் ப்ராடக்ட் பண்ணீங்கன்னா we get the Gaussian curvature. And arc length of the parameterization, if the generating curve is parameterized by the arc length s, then g dash of s whole square plus f dash of s whole square equal to 1. And kappa 1 equal to f dash of s into g double dash of s and f double dash of s into g dash of s, kappa 2 into f dash of s divided by g of s. Kappa under, this is the idea. Okay, and the surface given by z equal to h of r, now how to construct this one, and g of u equal to u, f of u equal to hu, and the surface given by the rotating z equal to h of r about the z axis. Then what is the kappa 1, what is the kappa 2, and curvature, principal curvature. And catenoid, the generating curve is the catenoid, and y equal to a cos h x by a. Okay, and rotating about the x-axis, this is the formula, g of u, f of u. From this we can construct the parametric form. And Gaussian curvature, kappa equal to k equal to minus 1 by a square cos h power 4 u by a. The minimal surface h equal to 0, constant negative curvature. And Zerosphere, generating tractrix, that is called g of u, f of u, u minus tan hu, and Gaussian curvature is minus 1 for this one, Zerosphere. And paraboloid, z equal to au square, generating curve, and g of u equal to u, f of u equal to au square, and the Gaussian curvature is 4a square divided by 1 plus 4a square u square whole square. This is area and volume of the formula. Surface area dA equal to, area element is dA equal to root of Eg minus f square du dv. That is when you substitute here we get this one. Okay, இங்க substitute பண்ணீங்கன்னா So surface area பார்த்தீங்கன்னா 2 pi the something 2 pi integral u1 to u2 and dA is here this one அதான் இங்கே போட்டிருக்கோம். And volume பார்த்தீங்கன்னா that is for the solid obtained by rotating y equal to f of x about the x axis na pi into f of x whole square x1 to x2. And then lines of curvature for the surface of revolution meridians is v equal to constant at the lines of curvature, parallels வந்து u equal to constant. Very earlier பார்த்தோம்னு நினைக்கிறேன் lines of curvature. The two families intersect orthogonally. அதே மாதிரி geodesics on the surface of revolution claret relation அப்படின்னு சொல்லுவோம். That is called the geodesic making angle theta with the parallels, that is g of u cos theta equal to constant. And types of geodesics வந்து meridians and always geodesics, and parallel on the geodesics only if g dash of u equal to 0. And find the Gaussian curvature of a cylinder. That is for a cylinder g of u equal to r, f of u equal to u for the cylinder. And we can compute that is derivatives, that is g of u equal to r and g dash of u equal to 0 with respect to u, and g double dash of u equal to 0, f of u equal to u, f dash of u equal to 1, f double dash of u equal to 0. Already we know that formula kappa 1 அதில் எடுத்து substitute பண்ணிங்கன்னா we get the 0, and kappa 2ல substitute பண்ணிங்கன்னா 1 by r வருது. These are principal curvature kappa 1 kappa 2. Gaussian curvature is the k equal to kappa 1 kappa 2, that is equal to 0. The cylinder has zero Gaussian curvature. The cylinder has a zero Gaussian curvature, that is called the developable surface. Okay. And show that the meridians and parallels are lines of curvature. That is first of all first fundamental form. This is the first fundamental form, and the second fundamental form. Okay, and the lines of curvature condition, the differential equation of the lines of curvature. This is the fn minus gm into du square en minus gl du dv em minus fl dv square equal to 0. Since f and m are equal to 0, so when you substitute here we get it en minus gl du dv equal to 0. So then the equation is satisfied when du equal to 0, that is parallel, that is u equal to constant, dv equal to 0 meridian, that is v equal to constant. So meridian and parallels are lines of curvature. This is a very simple flow. And the spherical coordinates, what is the spherical coordinate? For the surface symmetric about the origin, rho u sin u cos v, rho u sin u cos sin v, and rho u cos u. So this is the spherical coordinate. The cylindrical coordinate u cos v, u sin v, f of u. There is a surface symmetric about the z axis. And parametric form, x equal to pi of t and y equal to z equal to psi of t. Then when generating curve is given the parametrically, then r of t comma v equal to pi of t cos v, pi of t sin v, and psi of t. And surface area and volume obtained by numerical method, that is already discussed பண்ணிட்டோம். The next topic is the conjugate systems. The conjugate system to the differential geometry, that is conjugate system means conjugate net is a parametrization of the surface, where the coordinate curves have the special geometric relationship, coordinates curve or have a special geometric relationship related to the second fundamental form. So what's the proper definition for the two tangent directions du dv and del u del v at a point on the surface are called the conjugate. At a point on the surface are called the conjugate அப்படின்னு சொல்லலாம். The two tangent direction that is satisfy L du del v m into du del v dv del u plus n into dv del v equal to 0. The L m n la நமக்கு find out பண்ண தெரியும். That is called the coefficients of the second fundamental form. And the conjugate system is parameterization where the coordinate curves are u curve and v curve are conjugate to each other. Okay, this is the basic definition. So definition, example, that means problems, and relation to the second fundamental form. The conjugate condition can be written the second fundamental form, that is the du dv del u del v equal to 0. This means that the second fundamental form vanishes when evaluated on the two tangent direction. Two tangent direction evaluate panninga second fundamental form 0 ஆயிடுது அப்படினு அர்த்தம் for the conjugate condition. And envelope பார்த்தீங்கன்னா envelope two directions are conjugate if the corresponding asymptotic direction of the Dupin's indicatrix are harmonic conjugate with respect to the principal direction. And a developable surface, if we take that all tangent lines along the curve in one conjugate direction, they form the developable surface whose characteristic lines are in the conjugate direction. And condition for the conjugate coordinates for the parameterization R of u comma v to be conjugate system, we require that u curve and v curve are conjugate, that is m equal to 0. Very important. Simple question. And this is because of the coordinate curve u curve du dv equal to 1 comma 0, and for the v curve del u del v equal to 0 comma 1. So conjugate condition is that is the formula L into 1 into 0, that is equal to 0, that we get it m equal to 0. And in relation to the principal direction, that is f equal to m equal to 0, then the coordinates are both orthogonal and conjugate lines of curvature. Conjugate system are more general than the orthogonal system. Every surface admits the conjugate parameterization. And example பார்த்தீங்கன்னா lines of curvature of the coordinates for any surface, the lines of curvature form the conjugate system since f equal to m equal to 0. This is the most important example of the conjugate system. And another example, asymptotic lines on the negative curvature surface. So that is on the surface with Gaussian curvature is less than 0, then the asymptotic line form a conjugate system. Asymptotic line that is second fundamental form equal to 0 along the curve, so that in the particular for the coordinate asymptotic lines L equal to n equal to 0. So and the conjugate condition is automatically satisfied. For the third example, that is a sphere, the parametric form r sin u cos v, r sin u sin v, r cos u. Second fundamental form, this is the second fundamental form, L equal to minus r, m equal to 0, n equal to minus r sin square alpha. So since m equal to 0, the spherical coordinates form the conjugate system. And surface of revolution, general surface of revolution r of u comma v equal to this something parametric form. Then we get that m equal to 0, since all surfaces of revolution have conjugate coordinate system, that is meridian and parallels. And the properties of the conjugate system, every surface admits the conjugate parameterization. In fact, through each point there are the infinitely many conjugate directions. Each point infinitely many conjugate directions, so every surface admits the conjugate parameterization. Developable surface relation, that is if you take the curve C on the surface and construct the developable surface formed by the tangent planes along C, then the characteristic lines of this developable are conjugate to the tangent direction of C. And transformation properties, conjugacy is preserved under projection transformation, unlike the orthogonality which is the preserved under rigid motion. And differential equation, and given the parameterization, that is r of u comma v, and the condition for u comma v to be conjugate coordinate is m equal to 0, that is m equal to r u v into n, actual formula that is equal to 0. That means n is the unit normal here. Already நாம் பார்த்ததுதான். And this is the corresponding differential equation for the conjugate system. Equation ன்றது இதுதான், r u v my dot n equal to 0, n ன்றது unit normal, that is m equal to 0. Alternate form பார்த்தீங்கன்னா Weingarten equation, that is called the conjugate condition, can be expressed as dou square r by dou u dou v lies in the tangent plane, lies in the tangent plane. இல்ல r u v equal to, that is called the Cristobal symbol சொல்லுவாங்க, that is gamma of u v u r u v and gamma of u v v r v, that is called the gamma I j k k, that is called the Cristobal symbol. So மேலே இருக்கிறது தான் இது, இந்த ஃபார்ம்லேயே எழுதுவோம். This is called the alternate form of the differential equation of the conjugate system. And construction method from the given curve C on a surface, we can find the conjugate curve by solving the differential equation, this is equal to 0. For the conjugate direction, del u comma del v. And Gauss map என்றது two directions are conjugate if they are images under the Gauss map or antipodal points on the sphere. Antipodal points on the sphere. These are advanced examples. Hyperbolic paraboloid போட்டிங்கன்னா, that is what is that L, M, N and so this and ellipsoid பார்த்தீங்கன்னா, for the ellipsoid x square by a square, y square by b square, z square by c square equal to 1, the lines of curvature form a conjugate system. This is not a conjugate system. And relation to the other geometrical concept, asymptotic lines, if both L equal to 0 and the curve are conjugate, then U curves are asymptotic lines. Similarly, V curves is also asymptotic lines. Principal curvature, for lines of curvature which are conjugate, we have additional condition f equal to 0, that is called the orthogonality condition. And geodesics, conjugacy is an independent geodesics. A curve can be geodesics without being related to the conjugate direction. If Josmethel's theorem, that is the if two surfaces intersect along the curve, that is the lines of curvature on both surfaces, then the angle between the surfaces is constant along the curve. And Dupin's theorem, triply orthogonally system of the surface, the curves of intersection are conjugate on each surface. So find the conjugate system now, that is parameterization formula RU, RV, RUV and unit normal and m equal to 0 போட்டிங்கன்னா we get the result. You show that asymptotic lines form a conjugate system on a surface with Gaussian curvature is less than 0. So what is the definition of asymptotic lines? A curve is asymptotic if its normal curvature is 0. Normal curvature is 0, second form is 0 along the curve. So therefore coordinate asymptotic lines, if you take the asymptotic lines as a coordinate curve along the u curve, second form is become like that, that is L equal to 0. Okay, L du square, 2m du dv, n dv square. And along the v curve, L du square 2m du dv, n dv square, that is n dv square equal to 0, n equal to 0. Conjugate condition for the coordinate curves to be conjugate, that is we need m equal to 0. Both L equal to n equal to 0, the conjugate condition is become m equal to 0. So on the surface with Gaussian curvature is less than 0, asymptotic lines can be chosen from form a conjugate system. This is the one of the example to find the conjugate system for the surface z equal to x square minus y square. So first step enna pannum, parametric form eduthanum, that is u comma v, x equal to u and y equal to v and z equal to, given that x u square minus v square. So ru, rv இதெல்லாம் find பண்ணனும் and ruu, ruv, rvv and then try to find the unit normal. What is the unit normal? That is ru cross rv and modulus of ru cross rv. ரெண்டுத்தையும் டிவைட் பண்ணிங்கன்னா யூனிட் நார்மல் கிடச்சிரும். அண்ட் தென் LMN ஃபைண்ட் அப் பண்ணுறோம். LMN கண்டுபிடிச்சிட்டு செகண்ட் ஃபண்டமெண்டல் ஃபார்ம். ஸோ த கான்ஜுகேசி பார்த்தீங்கன்னா தட் இஸ் m equal to 0. So that the coordinate curves u comma v already form a conjugate system. And that is z equal to x square minus y square is a hyperbolic paraboloid. The coordinate lines are x equal to constant, y equal to constant, or straight lines on the surface and form the conjugate system. Therefore, z equal to x square minus y square, the coordinates x comma y themselves for the form a conjugate system. X axis, y axis, that is xy coordinates. The next pathina asymptotic lines. The asymptotic lines are curves on the surface along which the normal curvature is 0. Along which the normal curvature is 0. And that represent the direction in which the surface doesn't bend away from its tangent plane. What is the mathematical concept of a curve C on the surface S is called the asymptotic line. And the curve on the asymptotic line solnona, if at every point of C the normal curvature vanishes. Normal curvature 0 varda every point of the curve, that is called the asymptotic line. And in terms of the second fundamental form, the curve with the tangent direction du comma dv asymptotic, that is called the asymptotic in solona. Second fundamental form, this is the second fundamental form, equal to 0. Okay. And geometric interpretation, 0 normal curvature, and relation to the Dupin's indicator. Along the asymptotic line, the surface doesn't curve away from the tangent plane in the direction of the curve. So the osculating plane of the curve coincide with the tangent plane, that is called the of the surface, that is a 0 normal curvature. And the relation to Dupin indicatrix, elliptic form. On Dupin's indicatrix, the asymptotic direction corresponding to the points at infinity. For elliptic point, Gaussian curvature should be positive, no real asymptotic direction. And hyperbolic points, Gaussian curvature is negative, 2 real asymptotic direction. And parabolic points, Gaussian curvature 0, 1 asymptotic direction. Okay. And asymptotic line represents the direction in which thin flexible surface can be bent without stretching. And existence and classification by Gaussian curvature, this is greater than 0, already I have பார்த்ததுதான். And differential equation, the second fundamental form, that is become the differential equation. This is the quadratic equation in dv by du. So dv by du எல்லாத்தையும் du square ஆல divide பண்ணீங்கன்னா உங்களுக்கு இந்த ஃபார்முலா எழுதலாம். இதுவும் சேம் தான். And examples of the surface with asymptotic lines, that is hyperbolic paraboloid. Hyperbolic paraboloid, that is z equal to xy. This is one of the example. இதனுடைய parameterization பார்த்தீங்கன்னா x equal to u, y equal to v, z equal to uv. இதனுடைய first fundamental form, second fundamental form. Asymptotic equation பார்த்தீங்கன்னா second fundamental form equal to 0. Okay, already find out this is equal to L into 0 and 2 into m nuடைய value du dv, and this is equal to plus 0, equal to 0. So from this du dv equal to 0. So asymptotic line என்ன வருது, du dv equal to 0 na, du equal to 0 na, u equal to constant, v equal to constant are the asymptotic lines. These are straight lines, and the asymptotic lines are straight line. இதே மாதிரி one sheeted hyperboloid, this is called the hyperboloid. X square by a square, y square by b square, minus z square by c square equal to 1. The surface has two families of straight lines ruling, that is which are called the asymptotic lines. The next example is helicoid. Helicoid என்றது, this is called the parametric form. அதனுடைய Gaussian curvature is less than 0. அப்படின்னா two families of asymptotic lines are there. That is ruling that anti-ellipses. Okay. And இதுக்கு two families of straight line rulings, that is called the which are asymptotic lines. And torsion and curvature. Along the asymptotic line, the torsion tau is related to the Gaussian curvature. So the tau square equal to minus Gaussian curvature. This is called the Beltrami-Yenneper theorem. Okay. And geodesics and asymptotic, the curve can both asymptotic and geodesic na. In fact, straight lines on the surface are both straight lines on the surface are both asymptotic and geodesics. And the conjugacy property, asymptotic lines form the conjugate system if both families of the coordinate curves are asymptotic. Both families of coordinate curves are asymptotic, then asymptotic lines form the conjugate system. Then L equal to n equal to 0. And using the second fundamental form, direction du comma dv is asymptotic. Second fundamental form apply paniya, this is equal to 0. Using the shape operator, that is direction v is asymptotic na, like this. Okay, the shape operator, leave it. Using the normal curvature in the direction v, the shape operator use panni potukken, you normal proceed pannalam. Then normal curvature equal to 0, the second fundamental form equal to 0. And general procedure பார்த்தீங்கன்னா LMN கண்டுபிடிக்கணும் and quadratic equation கிடைக்கும் அதில் lambda equal to dv by du and integrate the resulting differential equation, then we get the solution that is called the asymptotic lines. And the special case பார்த்தீங்கன்னா L equal to n equal to 0 na the equation become the 2u du dv equal to 0 அப்படின்னா asymptotic line u equal to constant v equal to constant ஆகிடும். if m equal to 0 னு பார்த்தீங்கன்னா this is equal to 0 இதில் வந்து dv by du equal to plus or minus root of minus L by n னு வரும். இதை சால்வ் பண்ணிங்கன்னா ஓகே dv இங்கே வச்சுட்டு இதை அந்த சைடு கொண்டு போயிட்டு சிம்பிளி பண்ணிங்கன்னா these are advanced example, leave it. This is the ruled surface, and on ruled surface the ruling or asymptotic lines. In fact, surface is ruled if and only if it has the family of straight lines, asymptotic lines. Developable surface means Gaussian curvature equal to 0. Generators are asymptotic lines. Conjugate system means if both families of coordinate curves are asymptotic, then the parametrization is called the asymptotic parametrization. If I find the asymptotic lines on the surface, the same surface z equal to x square minus y square. இதனுடைய parametric form and RU, RV and RUU, RUV, RVV எல்லாம் find up பண்ணிட்டு unit normal கண்டுபிடிச்சிட்டு LMN கண்டுபிடிச்சிட்டு and second fundamental formula apply பண்ணீங்கன்னா உங்களுக்கு ஒரு output கிடைக்குது like this. So this is called du minus dv equal to 0, du plus dv equal to 0. இதை integrate பண்ணீங்கன்னா u minus v equal to constant, vu plus v equal to constant. And the asymptotic lines என்றது இதுதான் u minus v equal to constant. In terms of xy ல எழுதுனீங்கன்னா x minus y equal to constant, x plus y equal to constant. So on the minimal surface, prove that on a minimal surface the asymptotic lines are orthogonal. Okay, with the result on ஆபோச்சுங்க. So what is the minimal surface? Minimal surface has mean curvature h equal to 0. h equal to 0, the kappa 1 plus kappa 2 equal to 0. So principal curvature asymptotic direction makes an angle theta with the principal direction. So this is the kappa n, that normal curvature equal to kappa 1 cos square theta, kappa 2 sin square theta. So kappa 2 equal to minus kappa 1. I put in a kappa 1 common ஆக எடுத்துட்டா, that is cos square theta minus sin square theta. That is cos square theta minus sin square theta equal to 0. So cos square theta equal to sin square theta. From this tan square theta equal to 1, then tan theta equal to plus or minus 1. So theta equal to plus or minus pi by 4 னு வந்துரும். Angle between the asymptotic lines பார்த்தீங்கன்னா the two asymptotic directions makes an angle pi by 4 and minus pi by 4 with the first principal direction. The angle between them is pi by 4 minus or minus pi by 4, that is equal to pi by 2. On the minimal surface the asymptotic lines are orthogonal. Therefore asymptotic lines வந்து are orthogonal னு அர்த்தம். This is the special case. Umbilical points, and that means kappa 1 equal to kappa 2. That is if Gaussian curvature is greater than 0, no asymptotic direction is exist. Kappa equal to 0, all directions are asymptotic. All directions are asymptotic. And another case for the planar points, that is at planar points LMN equal to 0, all directions are asymptotic. And the next one is isometric lines. So the isometric lines means are called the isometric coordinates or isometric parameter, refer to the special parameterization of the surface where the first fundamental form has particularly simple structure. The isothermal coordinates, the first fundamental form is proportional to the Euclidean metric. What is the mathematical definition? That is isometric or isothermal சொல்லுவாங்க. The parameterization R of u comma v of the surface is called the isothermal and isometric if the first fundamental form satisfies I equal to lambda of u comma v du square plus dv square. The lambda of u comma v என்றது greater than 0 is a positive function. This is called the positive function. Isothermal coordinates is E equal to g equal to lambda of u comma v and f equal to 0. This is the first fundamental form. Okay, this is the mathematical definition. Definition ரொம்ப முக்கியம் எல்லாத்துக்குமே. Okay, and simple examples. At least ஒரு ப்ராப்ளம் ஆவது எப்படி போடுறதுன்னு தெரிஞ்சுக்கங்க. And isothermal coordinates, that are isometric points, that is called the isometric lines, the coordinates represent the conformal mapping from the parameter domain to the surface, the angle that means conformal mapping means angles are preserved and a small circle map the small circles and mapping the angle preserving but not necessarily distance preserving, that is called conformal mapping. Once again namu complex la padipom nenikiren. And the metric properties the coordinate curves are orthogonal, isothermal coordinate curves are orthogonal, that is f equal to 0, and u curve and v curve are isometric to each other locally, and metric is conformally Euclidean. And every sufficiently smooth surface, this is one of the important surface admits the local isometric lines, that is called the isothermal coordinates. And every simply connected Riemann surface is conformally equivalent to the other to either the sphere or plane or disk, either sphere, plane or disk. Okay, the complex analysis holomorphic functions to construct the isothermal coordinates. And the Beltrami equation, that is dou f by dou z bar equal to mu into dou f by dou z, and the numerical the discrete conformal mapping algorithm, that is the construction method. And the examples pathina plane la pathina the standard Cartesian coordinate on the plane are isothermal, that is u comma v equal to 0 parametric form. Already first fundamental form du square plus dv square, in this case lambda u comma v equal to 1. For the another example sphere coordinate on the sphere are not isothermal, but stereographic projection gives the isothermal coordinates. Stereographic projection means r of u comma v equal to 2u divided by 1 plus u square plus v square 2v by something. Here 1 minus u square by u minus v square divided by 1 plus u square plus v square. அதோடைய first fundamental form corresponding கண்டுபிடிக்கலாம். So EFG லாம் கண்டுபிடிச்சு then we get this one. From this what is the lambda of u comma v, lambda என்னன்னு பார்த்தீங்கன்னா this is the lambda. And another example cylindrical coordinate பார்த்தீங்கன்னா on the cylinder are isothermal, this is the form. இதை வச்சுட்டு first fundamental form கண்டுபிடிக்கலாம். This is not isothermal unless the reparameterized w equal to ru, ன்னு போடலனா this is not a isometric lines. So that is isometric line இருக்கும்னா then I equal to dw square dv square w ன்றது ru இருக்கணும். Okay, and catenoid அதனுடைய parametric form இது. This is as the isothermal coordinate. What is the isothermal coordinate? This is the isothermal coordinate. So first formula போட்டா காமனா வெளிய எடுத்து du square plus dv square எடுத்து முடிஞ்சனா that is called the lambda. And the properties of the isothermal coordinates, that's mean isometric lines. So in isothermal coordinate there are many formulas simplified, that is Gaussian curvature minus 1 by 2 lambda delta of log lambda, delta ன்றது Laplace operator இந்த இடத்துல, that is du square plus dv square like that in u comma v plane. And Cristobal symbol விட்டுருங்க, அது வேணாம். Okay, well, that is the expression. And minimal surface பார்த்தீங்கன்னா minimal surface in isothermal coordinates the coordinate functions are harmonic, that is delta x delta y equal to delta z equal to 0. And conformal invariance பார்த்தீங்கன்னா that is many geometric quantities are simplified in isothermal coordinates, that is the Laplace Beltrami operator delta s f equal to 1 by lambda delta f. Geodesic equation simplify and complex analysis technique becomes applicable. Okay, leave it to this one. And necessary and sufficient condition and parameterization r of u comma v is called the isometric line சொல்லணும்னா if and only if mod of ru equal to mod of rv ஆ இருக்கணும், இல்ல ru dot rv equal to 0 ஆ இருக்கணும். In complex formulation that is called the z equal to u plus iv na the parameterization is the isometric line ஆ இருக்கணும்னா dou r by dou z equal to dou r by dou z bar whole square, mod of dou r by dou z whole square equal to mod of dou r by dou z bar whole square. That means in metric ds square equal to lambda into mod dz square ன்னு அர்த்தம். Okay, the finding the isothermal coordinate for the surface revolution, this is the for the surface revolution the isometric metric lines g dash of u whole square f dash of u whole square equal to g of u whole square. This is the ODE, first order differential. This solve panningana we get that corresponding equation. And the complex analysis holomorphic function w of z such that new coordinate is called the isothermal lines. And helicoid r of u comma v equal to u cos v and u sin v is not a isothermal coordinate. And first formula நீங்க போட்டீங்கன்னா உங்களுக்கு இப்படி வருது. First fundamental formula போடும்போது இப்படி வருது, காமனா வெளிய எடுக்க முடியல. So this is not a isometric lines. Okay, it can be reparameterized to the isothermal form. எப்பனா w equal to sin h inverse u னு எடுத்தீங்கன்னா it's become the isothermal coordinate இல்ல isometric line ஆ மாறும். Okay. And NFS surface இவ்வளவு காம்ப்ளிகேட்டடா கேட்க மாட்டாங்க. But இதெல்லாம் கொஞ்சம் NFS surface is the classical minimal surface, simple isothermal coordinates, that is the form. Okay. And zero sphere is called as isothermal coordinate, that is I equal to 1 by v square into du square plus dv square. And verify the stereographic projection gives the isothermal coordinate on the sphere. What is the stereographic projection? இப்போ தான் பார்த்தோம் just. இதெல்லாம் கொஞ்சம் ஈஸியாக ஞாபகம் வச்சுக்கலாம். Rன்றது and problem solve பண்ணுறது கொஞ்சம் டிஃபிகல்ட்டாக தான் இருக்கும். And RU D equal to the 1 plus u square plus v square, that is like this, d square வச்சுட்டுங்க. And RU கண்டுபிடிக்கலாம், RV find out பண்ணணும். RU, RV and RU into RV, the first fundamental form E and F, G எல்லாத்தையும் find out பண்ணி எடுத்து substitute பண்ணீங்கன்னா காமனா வெளிய எடுத்துட்டு this is the form, lambdaன்றது இது வருது. So this is called the isometric lines. So calculation work கொஞ்சம் difficult-ஆ இருக்கு, அவ்வளவுதான் differentiate பண்றது. So இல்லைனா memorize பண்ணி தான் ஆகணும். And catenoid as a isothermal coordinate, catenoid அதனுடைய parametric form இது RU, RV. So நம்ம first fundamental formula apply பண்ணிட்டு lambda into something எழுத முடியுதான்னு பார்க்கணும். So first fundamental formula apply பண்ணீங்கன்னா I equal to cos h. முன்னாடியே இந்த ரிசல்ட்லாம் கொடுத்துட்டோம். Okay, இது this is the problem case, அவ்வளவுதான். And finally geodesics. Geodesics are the analogous of the straight lines on a curved surface and the path of the shortest distance between points and have a zero geodesic curvature. So what is the mathematical definition? Suppose curve gamma s on the surface S is a geodesic அப்படின்னு சொல்லலாம். It's a geodesic curvature kappa g is identically 0. Kappa g ன்றது is identically 0 with respect to s, that is kappa g of s equal to 0 for all s. The geodesic is a curve whose acceleration vector is normal to the surface, that is the second derivative of the gamma s. Gamma s is the curve orthogonal to t gamma of s. Okay. So geometric interpretation பார்த்தீங்கன்னா shortest path. Geodesics are locally length minimizing curve. Length minimizing curve is called the geodesics. Between the points on the surface. Between the points on the surface. Okay. That is the straight path or the straight as possible. They have no acceleration component tangent to the surface. And geodesics represent the path of free particles moving on a surface under no external forces. Geodesic equation that is very important, that is in the first fundamental form. This is the first fundamental form. Geodesic equation using the Christoffel symbol use பண்ணி express பண்ணிருக்காங்க. And variational formulation பார்த்தீங்கன்னா this is called the geodesics or critical points on the length functional. That means length, arc length formula அது. And the example பார்த்தீங்கன்னா plane. இந்த planeல பார்த்தீங்கன்னா geodesics or straight line, that is r of t equal to something. And sphereல பார்த்தீங்கன்னா geodesics or great circle. இதெல்லாம் ரொம்ப முக்கியம். Okay, in the plane la what is the geodesics, sphere la what is the geodesics, and ஏன்றது கொஞ்சம் யோசிச்சு பாருங்க. That is the shortest path. This is the shortest path. And a cylinder பார்த்தீங்கன்னா on a cylinder, okay, geodesics are meridians, that is u equal to constant and v equal to constant, but only if they are not curved. Okay, ellipses satisfying the Clairaut's relation. And a cone பார்த்தீங்கன்னா on a cone, geodesics can be found by unwrapping the cone to the plane and drawing the straight line. And properties பார்த்தீங்கன்னா through any point or in any direction there exists a unique geodesics. And the geodesic completion, Riemann manifold is a geodesically complete if all the geodesics can be extended to infinitely. And the surface of revolution, geodesics makes angle theta with the parallels, then r cos theta equal to constant, r into the distance from the axis. And the Gauss-Bonnet theorem, this is called geodesics triangle whose sides are geodesics, triangle whose sides are geodesics, that is for geodesic triangle. Double integral the Gaussian curvature dA equal to alpha plus beta plus gamma minus pi. The alpha beta gamma la enna interior angles of the triangle, interior angles of the triangle. So ellame na important ah dhaan kuduthirken. Jacobi field describes how geodesics spread apart and satisfy the Jacobi equation d square j divided by d square r of j comma gamma dot equal to 0. So r is the Riemann curvature tensor. Yeah. This is the advanced example, ellipsoid and hyperbolic plane and torus. The exponential map the TPM to M sends the tangent vector v to the point reached by traveling along the geodesics with initial velocity v for unit time. Geodesic curvature means that is kg, that is measured how much the curve deviates from being a geodesic, that is dt by ds comma n cross t, that is the inner product. dt by ds is the covariant derivative of the unit tangent. So find the geodesics on the cylinder node parametric form and the first fundamental form, and then Cristobal symbol, that is konjam memory panni aganum for this one, gamma 111 u by 2e, and differentiate e with respect to u nu artham, that is equal to 0. E12 gamma 1 to 1 என்றது this is equal to ev by 2e, and gamma 2 to 1 என்றது minus gu by 2e, gamma square that is 1 1 என்றது minus ev by 2g. Okay, and gamma 1 to gu by 2g and gamma 2 to 2 என்றது gv by 2g. So எல்லாமே இங்க 0 வருது. So that geodesic equation is become d square u by ds square equal to 0, d square u by ds square equal to 0. Okay, and then the equation is become the either integrate பண்ணீங்கன்னா u equal to as plus b, இது integrate பண்ணா vs equal to cs plus d. So the geodesics are u equal to constant, the geodesics are meridians, that is u equal to constant, a equal to 0, when a equal to 0, when c equal to 0, v equal to constant, that is called the parallel. But these are geodesics only if they are straight lines. So ellipses பார்த்தீங்கன்னா u equal to as plus b, v equal to c equal to general case. So on the cylinder பார்த்தீங்கன்னா geodesics are ellipses including the meridians and parallels, எல்லாமே டிஸ்கஸ் பண்ணலாம். And the great circle or geodesics on a sphere. So r of theta அதனுடைய parameterization form. Consider the great circle in the xz plane. xz plane la, that is y equal to 0. அப்படின்னா r cos s by r, this is r sin s by r, gamma of s equal to the curve, அதோட derivative gamma double dash, and the normal curvature condition பார்த்தீங்கன்னா that is acceleration gamma double dash of s is parallel to the position vector or gamma of s which is normal to the sphere. So this is gamma double dash of s perpendicular to T gamma of S. Yes. This is the tangent. Okay. So that is a general great circle. Any great circle can be obtained by rotation, and the rotation preserves the geodesics. So all great circles are geodesics on the sphere. Result ஞாபகம் வச்சுங்க, problem புரியலனா. It's sphere க்கு what is the geodesics? And use Clairaut's relation on the surface of revolution. And the surface of revolution, this is the surface of revolution. Clairaut's relation for a geodesics makes angle theta with the parallels g of u cos theta equal to constant. So then for the cone, the vertex angle is 2 alpha. So g of u equal to u sin alpha, f of u equal to u cos alpha. The Clairaut's relation u sin alpha cos theta equal to constant. If c equal to 0, then cos theta equal to 0, theta equal to pi by 2, that is the meridian geodesics. C equal to u naught sin alpha na, then at u equal to u naught, then cos theta equal to 1. So geodesics is a tangent to the parallel. Okay. So Clairaut's relation provides the first integral for the geodesics on the surface of the revolution. Okay, that's all. Then already பார்த்தது தான் நம்ம